Hello everyone, welcome to Unit 4, Lesson 3, Naming Ionic Compound Notes. For this, you should be able to explain the rules for naming binary ionic compounds. This includes both transition metals and alkaline or main body elements. That includes like our alkali metals, our alkaline earth metals, and a couple exception rules. So for this, transition metals can have more than one charge. How can we determine the charge on the following metals? To review a little bit from the previous set of notes, I went over something called the trade rule, or trade to cancel. So if I have copper chloride, which is CuCl2, there's an invisible 1 here and a 2 here. I can trade back the numbers, and I know that this should have a magnitude of 1 and a magnitude of 2 here. Well, we know that copper is a metal, so it forms a cation, so this should be 2+, and then chlorine we know is in group 7A, so it should form a 1- charge. So the trade back allows us to figure out what the charge is, and then we can use what we know should happen, so the sign and the fact that chlorine has to form that 1- charge to check and make sure we didn't reduce the ratio. Because like ratios, sometimes if you have 2 to 4, you can reduce that to 1 and 2. So for copper fluoride, we have a 1-to-1 ratio. So when we trade back, we need to check and make sure that fluorine does indeed form a 1-, because it's the anion, a 1- charge. And it is in the same group as chlorine, group 7A, and they all form that 1- charge. So that means that for certain, this copper ion is a 1+ charge. And briefly we discussed how transition elements are a little tricky, and this is why they can form multiple charges. And we're going to dive into that in this lesson. So in the lesson, you're going to work as a POGL. Now you can complete the notes first and then do the POGL, or do the POGL and then complete the notes. Just make sure once you are doing the POGL, you work with your group and check your work as you go. A stamp may or may not be available depending on what day it is. Okay, notes can be after. However, because we're self-pacing, that is up to you. Okay, so ionic compounds. We talked about it in Lesson 2. Now we're talking about it again here in Lesson 3. Form between metals and nonmetals. We can generalize this a little more and say cations and anions. Okay. We have a couple rules for these, and the first one is for those that form only one ion. These are in groups 1A or 2A and can only have one type of ion. I want you, though, to write on your periodic table, additionally, we have zinc, which only forms the 2+ charge. Aluminum only forms the 3+ charge. There's 6 of them. Indium, 2+, gallium, 3+. Oops, indium is 3+. My apologies. 3+. Cadmium is 2+, and then silver is a 1+ charge. So all of these will follow this specific rule, where we just write the metal, its name, and then we write the nonmetal but change the ending to IDE. So for example, CaCl2, Ca is calcium, so we just write its name, and then Cl2 or Cl is chlorine, but when it becomes an ion, we change it to ide, chloride. Okay, so let's look at some examples for this. So Li3N, right? Following the rules, we write the metal name, so Li is lithium, and we don't have to do anything with the 3. And then N is nitrogen, but we write it as nitride. Okay, because these form in very specific ratios based off of the charges that the ion always forms, we never for ionic compounds have to specify how many we have. We never say in the name trilithium. That does not happen because it is implied due to the nature of it being an ionic compound. Okay, Transition elements are a slight exception to that, but we never say how many. We will say what type of charge it has. Looking at strontium is Sr for our next one, so strontium. And then S is sulfur, and we change that to sulfide. And then for beryllium, Be is beryllium. And then I is iodide. Going the other way, if I had as an additional example, magnesium bromide, I write my symbol for both of them. I determine the charge, and magnesium is in group 2A, so those all form 2 positive charge. Bromine is in group 7A, so it forms a 1 minus. They are not equal, so I'm going to take their charge numbers and trade them to cancel. So 1 and 2, so that gives me a positive 2 and a negative 2 total, which do add to 0. So I would write MgBr2. I do not have to write the 1. It is implied by that symbol being there. And so that would be the formula for magnesium bromide. What happens though if they form more than one type of ion? So if the metal is a transition block or in group 3A, 4A, with the exception of the ones written here, it could have more than one charge. We have to indicate the charge using Roman numerals. You need to be able to identify through 7. So Roman numeral 1, 2, 3, 4, 5, 6, and 7. So you need to be able to identify all of those. Okay, and knowing how to use those Roman numerals. There's a way, remember, the trade to cancel. So Roman numeral is what we're going to use, and that represents the charge on the metal. Okay, so when we write iron chloride, when we are trying to figure out what the charge on iron is, remember our trade back rule to figure out our charges. This is 2 plus, and so this is 1 minus, because the metals are always positive, and chloride is in group 7A, so it does form that 1 minus charge. So this is the correct charges, because this matches what it actually forms. So we would say iron for Fe, its charge as a Roman numeral, so iron 2, and then write the non-metal name, chloride. However, remember we have some exceptions where it's silver iodide. I believe that I did put this with a Roman numeral 1. The technical correct term is without the Roman numeral, but since it is a transition metal, if you end up using the Roman numeral, I will not take off points. Okay, so let's look at some additional examples. So here we have manganese, so we start by writing the names. And then chlorine becomes chloride, so the starting is the same as the previous type, so where we just write the name and change the ending. But now because manganese is a transition metal, I need to figure out what its charge is. So I trade back, and this is a 2 plus and a 1 minus. Okay, so that tells me that this is manganese 2 chloride. Repeating this for the other ones. So CO, cobalt, and sulfur becomes sulfide. So cobalt, and then sulfide. It is a 1-to-1 ratio. However, if we look at the periodic table, sulfur forms a 2 minus charge when it becomes sulfide. So that means that in order for these two to have a 1-to-1 ratio, cobalt has to have the exact same charge but opposite sign, so that they do add to 0. So when we write this, we are going to write cobalt and then in parentheses 2. Cobalt 2 for our answer. Cobalt 2 sulfide, because that's the charge on cobalt. We repeat this. We see there's a 1-to-1 ratio with the iron and nitrogen. However, nitrogen forms a 3- charge. So that tells us that this must be a 3+ charge on iron, so that way they can maintain their 1-to-1 ratio. That tells you that their charges are equal but opposite when it's a 1-to-1 ratio. So we would write iron, and then the type of charge, 3, nitride, because we changed the ending of the anion to IDE. Okay. For an additional example, going the other direction, if we had chromium 4 oxide. Your first step is to identify the elements. So chromium is Cr, oxygen is O, then determine their charges. So chromium 4, that tells me that that is a 4+. Then oxygen forms a 2- charge. These are not equal, so I'm going to trade them. So a 4 here and a 2 here. But Cr2O4 is not the lowest ratio, so I am going to rewrite that and simplify to CrO2 because the ionic compound is always the lowest whole number ratio. Okay, so we always simplify it down. Okay, so that is the premise for naming ionic compounds. And I did the more examples in the thing. So complete lesson 3, naming ionic compounds, checking your work as you go. Make sure you answer the guiding question on page 8 in 2 to 3 questions to explain the rules for naming binary ionic compounds. Thank you guys for tuning in.